Hi, this is Eric at Drobo, and today we're talking about drive error handling in a storage array. So I'm going to walk you through how we handle errors in a Drobo storage array, and one of the big things about error handling with regards to drives is it's a redundant storage array, and one of the values of that is if you have a single drive failure or even two simultaneous drive failures, the array can protect you from losing any data or even having a downtime. So I wanted to give you an in-close look at how we do that in our arrays. And when your application, your server is writing data to the array or reading data off the array, it's interacting with all the drives in the array. And sometimes when you issue a write to a drive, you may get an error, or you try and read from the drive and it gives you an error, or it doesn't even give you the data you're looking for. Sometimes the drive goes unresponsive, and there's a lot of things we can do in the Drobo to ensure that we get the data that you need accurately and can write the data properly. So as drives error occur, for each drive in a Drobo, we're creating a counter or a table. And sometimes you get one drive error, or sometimes the drive's unresponsive, and we may need to reset it, or the drive just may be not responsive, may time out, and we have to reissue a command, and we'll track these as they go on the drive. And sometimes you may even encounter a bad block on a drive where we go to try and get the data, and the data's just gone, or the data's wrong, but a Drobo's redundant, so we can then take that redundant copy, map those blocks as bad, copy them to another location on a good drive or on a good part of that same drive, and you can continue on. And and we can keep counting this stuff. And then at some point, there's a point in time where a drive becomes in an unhealthy state. And even though the drive, we can read and write to it sometimes, you'd want to mark that drive as bad. And when that drive is marked as bad and we want another drive to be utilized, on the front of a Drobo, let's say if it's this drive that that went bad, we'll turn the light red, we'll blink the light red, alerting you that you need to remove that drive. Now Drobo will automatically rebuild with the available free space in the Drobo, rebuild back to a protected state, and the rest of the lights will go green, and that happens automatically. The other nice thing that Drobo does is when the system's idle, when the array is not being frequently accessed, being written to or read from, in the background Drobo will go and check areas of the drive that haven't been read in a long time to ensure that data can still be accessed. If Drobo happens to stumble across an area of a drive that data's not there anymore, we can then take its redundant copy and remap it. So when you're actively using the array, we're always checking the drives, and even when you're not actively using the array, we're leveraging that free time to go around the array and find challenging areas. So Drobo is a very automated storage array, and this is just one of the ways Drobo operates behind the scenes to ensure it stays as healthy as possible.